Hello and welcome everyone. Thank you for joining us today for our webinar titled, What is AutoML? My name is Shabar Pula and I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speaker. Today we have Rafael Cos, Product Marketing and Community Maker at H2O.ai. Before I hand it over to Rafael, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the Questions tab in your console. We'll be happy to answer them towards the end of the webinar. This webinar is being recorded. A copy of the webinar recording and slide deck will be available after the presentation is over. Without further ado, I'd like to hand it over to Rafael.
Thanks, Shabar. Hi, folks. My name is Rafael Cos, as Shabar mentioned, and today's topic is on what is AutoML. So I have been in the software and data and analytics business for almost 25 years, and I've been really focused on the bleeding edge for those 25 years, and now I'm here with H2O.ai and really focused on AI. And one thing I'm really excited about is this whole notion about democratizing AI. And so as we talk about AutoML, one of the key aspects of AutoML is in my opinion, it's going to be very much a key factor in being able to democratize AI, really make AI sort of available to a lot more folks, right? So today I want to talk a little bit about this, what is AI, maybe give you a little introduction about H2O.ai, and then dive deeper into this, how AutoML is really going to play that role in democratizing AI. And then towards the end, I'm going to do a quick demo to kind of see AutoML in action, and then we'll kind of wrap it up for a series of questions at the end. So H2O, if you never heard of us, we're the open source leader in AI and machine learning, and we have this mission to democratize AI for everyone, right? And that democratization happens in a couple of different ways. Part of that is, we have a series of open source projects, and we're contributing into the open source. Part of that is by making just things, the tools easier, right? And I think AutoML is a great tool to help level the playing field around access to AI. And I think the other aspect about democratizing AI, it's not just the technology, but it's the knowledge, right? Like learning about AI and machine learning. And so we have a whole series of assets and a learning center and initiatives to help democratize the knowledge around AI. And so with that, we really want to help make your company into an AI company. And so whether you're a large tech company or a small, medium business, we really want to see AI as something that everyone can leverage across every single industry, right? And AutoML is going to be a key aspect of that. So as we look at, democratizing AI, as I mentioned, there's a whole community aspect in democratizing the knowledge and helping folks in AI who are trying to get started to learn more about AI. And then we have our AI for Good initiatives, and we really see ourselves as a partner with the extended open source community and also with our customers. So we've been around since 2012. We just recently got our Series D funding. We have a very diverse set of investors. We're about 240 people. About 20,000 people are using H2O every day, right? And over 1,000 universities have now sort of made H2O and our AI and machine learning technology part of their curriculum, right? And we have a very active, a meetup community if you wanted to kind of keep learning more, right? So as we look at our team, one interesting aspect of our team is, we have now, I think, 15 Kaggle Grandmasters, right? So we have these expert data scientists. Some of them are Kaggle Grandmasters, some of them are expert data scientists from industry, and these are the folks who are driving the technology and the evolution of our products, right? And so they really have the pulse of where AI is and have a passion for figuring out how to simplify it and get it in the hands of everybody. And we've been at this for several years, and we were sort of recognized across the industry for being a leader in AI and in automatic machine learning. So in this last year in Gartner, there was 2 Magic Quadrants, and we placed as visionary in both of them. And in one of them, we were the most completeness and vision farthest to the right. So as you kind of look at the technology and what we have to offer, we're sort of recognized as a leader in what we do around AI and automatic machine learning. So as we look at, AI, kind of let's, start getting to the topic at hand is, we want to make every company into an AI company. And machine learning is going to play a key role. So there's a whole process in which you collect requirements, understand the business, start doing data engineering, start building models. This can be a very iterative process. At some point, you may go from building models to deploying a model, and at some point, you're going to go through some iterations there, and then you'll end up being an application. So it can be at times a very complicated process. There's a lot of knowledge and understanding both of the business and the technology that are key to make an AI project successful, right? And a key part of that is what's happening around the whole machine learning, right? And that's where AutoML is going to play a key role to help democratize that knowledge. So as you see AI, it's definitely heating up, whether it's, even in these troubling times, we've still seen a large pickup in what's interest in customers around AI, whether that's, customers who are implementing projects or people looking for skills, people with skills in AI, right? Or how would they prioritize? In some ways, more than ever during these times, we want to have the best understanding of what's happening in your business and try to forecast what's going to happen next, right? And so AI is something that can be used across every single industry, whether it's financial, healthcare, life sciences, telecom, marketing and retail, et cetera, right? And what we're looking to do is, figure out how we can make this as efficient as possible, help companies save time, save money, and gain a competitive edge. So with that, what challenges have we heard from customers as they try to embark in this AI journey, right? And so everyone's trying to better their analytics, want to better understand and participate in this AI journey. And some folks have gone farther along that journey, right? But at the same time, some folks are struggling with scale. Hey, I want to do more. Some folks are struggling with getting started. Some folks are trying to accelerate how quickly they can move from exploring to production, right? And some folks are kind of looking at, hey, we're just getting started. Is there a simpler way where I can do it myself, right? And so that's where really, automatic machine learning can play a role. And if I summarize these challenges, we really see it as three main challenges. One is talent, getting the people and the team and the know-how to kind of accomplish this. Two is time, and the time is, again, we talked about that process that can be an iterative and time-consuming process at time. And some of that's the process, and some of it's processing time, right? Because as you do AI machine learning, there's a lot of compute that happens. And I really think to make AI successful, right, to leverage the decision capability of machines, we need to trust what these machine models are suggesting to us, right? And so it's not just about building these models quickly, it's about building models that we can trust, that we can explain, that we can communicate to other folks. So in some ways, I think, these three are the challenges: talent, time, and trust, right? And so as you're embarking in this, journey to become an AI company, AutoML, in particular an open and extensible AutoML platform, can provide, a key asset to make this easier, cost-effective, and just reduce the time to insights and better decisions, right? And so this, leveraging something like AutoML can really give your company this competitive advantage in the market because of the insights you can gain from your data. So as we talk about AutoML, right, I mean, it just software in general, there's been sort of an ongoing trend towards automation, right? Programming out software automation, making the programming more automated, being able to more easily build machine learning models, and, getting to a point where you actually can have automatic machine learning, right? And so, we want to automate as many of the tasks as possible to streamline this process. But, maybe not all the tasks can be automated. And this AutoML landscape is very diverse, right? There's lots of different vendors, some with commercial offerings. H2O has both H2O driverless AI and H2O AutoML. There's also open source offerings and other commercial offerings. So, how do you distinguish, are all these AutoMLs the same? What's the difference between them? How do I evaluate in sort of AutoML? So with that, let's talk a little bit more about what is AutoML. So Erin Liddell is one of our lead data scientists here at H2O.ai. She put a blog together in 2018 that's talking about the different flavors of AutoML, right? And so she defined AutoML as methods for model selection and or hyperparameter optimization. And these are things that automate this model selection and hyperparameter optimization. And she looked at it as it can really do two things. Well, one is enable non-experts to train high-quality machine learning models. And by the way, AutoML is for the novice and also for the expert, and to help improve the efficiency of finding the optimal model. Right? So even an expert, you want to make them more efficient in how they can get to that point where they can find that optimal model. And so if you want to learn more about the H2O3 AutoML, I shared here the link to a tutorial about learning more about H2O3 AutoML and the link to Erin Liddell's blog. So as we look at this whole machine learning process and we talk about automating, what exactly are we automating? So here's a view of a machine learning workflow, right? And so there's a whole training of data, exploring data, and there's multiple aspects to preparing data. And so there's an aspect to just preparing the data for machine learning, which basically means particular algorithms expect the data to be in a particular format to be able to work. And then you get into this very iterative process of tuning models, right? And so you got to select the model, you got to look at what hyperparameters are available for that model, what feature engineering you can do on that model to keep improving that signal. And then you want to iterate through that process. And maybe at some point you want to ensemble the best winning model to kind of get to your final model. And then you're going to go through a whole process of explaining models, reporting on models, and when you're, think you have a good model for your production, then you're going to start this whole phase of model engineering and packaging of models to kind of meet the production requirements and model management to kind of put the model in production and have your application consume the results of that model. So even in this diagram, you can see some of the complexity that's involved in generating this machine learning model. And today we're really going to focus on the top half of this diagram. So, the way I think of AutoML, AutoML is, it's about automating the tedious, exhaustive, and fine art of developing and evaluating the creation of a deployment-ready machine learning model, right? So, we just saw sort of a high-level workflow, right? And we talked about how this can be sort of iterative. And then there's a lot of knowledge, that fine art of understanding what you can do, which algorithms should you apply, what hyperparameters should you leverage, do you want to ensemble or not, and the whole aspect around feature engineering, right? So, and AutoML is something that can be both leveraged by non-experts and experts, right? And AutoML is something that's definitely continuing to evolve, right? So, like we mentioned, there's many vendors out there working in AutoML, but they have automated various aspects and have a particular ability to get to that best model that's deployment ready, how fast they can do that, and how good can they do that. One of the things we've done as we talk about democratizing AI, we put together an AI glossary, so you can see the bit.ly link there if you want to see our definition of what is automatic machine learning. And part of that is we really see this in this evolving space as having a series of generations of automatic machine learning. And this, and I'm going to walk through some of those generations. So in that first generation, we see a lot of open source folks building automatic machine learning tools. And initially, they're very focused on selecting an algorithm and doing some hyperparameters, right? And some other folks are getting more advanced and are starting to look at how to ensemble some of the best models and kind of create a leaderboard, right? And as we look at the second generation of automatic machine learning, then we start seeing folks not just do some basic feature engineering and feature encoding, but doing much more advanced engineering, right, to better find the signal and noise in the data, right? And then there's also adding things like, in looking at the automation, right, is automating how you can get a deployment-ready model, right, because it can be different requirements when you want to go to the deployment. So if you develop a model in Python, but your deployment environment is in Java, you might need to do rewrite. So, hey, can I streamline that piece? Can I streamline the explainability of a model, the reporting of a model, right? So there's more and more aspects that we're looking to adopt to further automate the process, right? And lastly, is like, really kind of in this third generation, really looking at the ability to make it open and extensible, right? So not just having something that can do it out of the box, which is great, but also having something where, hey, this out of the box capability can cover lots of different use cases, but what if I have an additional use case or a different algorithm, a different feature engineering technique that I also want to include in this automation? Can I leverage sort of an open and extensible automatic machine learning platform, right? And so that's what I see as the 3 generations of automatic machine learning. So if I take another look at that same workflow, right, and we kind of look at where we have a different automation in AutoML by some of the more leading tools, and this is where I would say the current sort of state of the art in automation is, right? So looking at exploring the data, doing some amount of preparation to get that data ready for the algorithm, right? And I say partially because there's a lot of work that's happening in this preparation phase, and more to more automation that's happening. And there's some vendors on the data prep that are doing some of this. There's some folks in the machine learning part that are doing some of this. And so that's definitely something that's continuing to evolve. But once you get into that darker gray block where you're kind of iterating through tuning the models and selecting the algorithm, there's a high degree of automation there. And there's also the capability to not just automate that, but also have some extensibility, right? So extensibility in the sense of what algorithms you can leverage, how you tune those algorithms, and also how you can complement what's already in what existing feature engineering exists in the tool with additional feature engineering, kind of adding your own IP from your business into this process, right? And then there's the ensembling that has been significantly sort of automated. Some tools like driverless AI can kind of give you a deployment-ready artifact, whether it's for Java or Python or C++. It makes it very easy kind of to train once and kind of deploy almost anywhere, right? And then you also have this whole automation that you need to happen around final model selection, right? So there's, you might have your lead data scientist involved in, how do we help that person understand the different experiments that we run and how to choose between them. And then part of that choosing is you want to understand that model, right, and get explanation for your model. And the other thing is that you want to communicate about the model, right? And in some industries, you can't put a model in production unless you've created a report. So can we also automate that sort of report building process? So another sort of view of this, right, is, there's a whole set of feature engineering capability, and there's some very basic feature engineering capability that's happening in AutoML that maybe isn't commoditized. And then there's sort of much more advanced feature engineering capability, and then the whole notion of being able to extend it and add your own feature engineering. I mean, that's really sort of the state of the art in automatic feature engineering. I think initially in that first generation, there's definitely that algorithm selection and parameter tuning. The thing to note here is that ML and AI is a very dynamic environment, right? So there's constant innovation. So this is where our grandmasters and lead data scientists are really staying abreast of all the changes and how we keep adding different algorithms, different hyperparameters, different ensembling techniques to keep helping you build the best model as possible, right? And lastly, there's all that, once you sort of built some models, how do you evaluate that, from explaining to documentation and reporting, right? So, today I want to show some demos with a tool called driverless AI. And so driverless AI is an automatic machine learning platform, and it leverages AI to do AI. and it can quickly deliver insights and build models quickly in an automated fashion. You know, you can do AutoML, but it's not just the insights, it's the interpretation of that, right? And one of the things that's interesting about Drivers AI is that it's an open, extensible automatic machine learning platform, right? And just a quick, review of AI platforms at H2O. So our first generation of platforms around the open source. So we have a tool called H2O, sometimes also referred to as H2O3, not to be confused with the company, right? It's the third version of H2O. And this is a distributed in-memory machine learning set of algorithms, right? And so this can work in Hadoop, in Spark, and now in Kubernetes, right? And so, and we have our first generation of AutoML that's there, and that's some technology that we continue to evolve and enhance. And sort of our second generation of this is Drivers AI, right, which is sort of now really focused on on automatic machine learning and kind of giving you a GUI so you don't have to code. You can code if you want to, but you don't have to code, and it really kind of democratize that access to the tool, right? And lastly, our latest iteration into these AI platforms is H2OQ, right? And so H2OQ is a platform to facilitate building AI apps. So if you listen to some of our webinars around COVID and applications, you start seeing all this tying together of the building the process, the building the model, deploying the model, and then building an application, right? And Q facilitates all those all together. So with that, as we look at automation, right? We talk about explaining and doing some exploration. So Drivers AI has some capability to do some automatic visualizations, right? And also kind of anything you see from the UI in Drivers AI, you can do via Python or R. But if you're a more novice user, or maybe you don't know Python and R, but you have a good statistics and some other technical background, and you want to start building models, we give you a GUI that provides some high-level nods, and there's many fine-tuning nods that kind of make it easy for you to get started, right? And we actually, this whole notion of AI today, we automate and give you suggestions for the initial tuning parameters, right? And not only do we help build the model, but we help explain the model, right? So we automatically can generate some explanations and do some reporting and create that deployment-ready artifact to kind of put into production. So as I look at Drivers AI, right, we have this, at the core we have an automatic machine learning model optimization engine, right? And that's kind of looking at different algorithms, optimizing for a particular score, doing the hyperparameter tuning, doing feature engineering, and at the end doing ensembling, right? And this can work for regression, classification, time series, NLP, and images, right? And so this is all can both run on CPUs and GPUs, and there's some storage and scheduler there for that infrastructure. But out the other end, it's going to have your MLI and AutoDocs. Right? And our deployment-ready artifact, we can do this in Python, and like I said, you can do it for Java, C++, Python, or R. So as we look at that extensibility factor, right? So there's ways where you can add additional scores, and like what is the tool optimizing to, add additional feature engineering techniques, bring your IP to it, or out of the box, Drivers AI uses the leading industry open source machine learning algorithms. But if there's something new or something additional or something for your particular use case you want to add, you can add additional algorithms into this automation. So as we look at a workflow, right, you get access to the data, and there's lots of different connectors. Bring a data set. Drivers AI is focused on supervised learning, which is learning by an example, right? So you have to have something where there's an example of where you want to find a pattern. And then it kind of enters this process of visualization, automatic machine learning, and then there's extensibility into that automatic machine learning. Sometimes we refer to that as, those building blocks as recipes, right? And you can bring your own recipe. That's the extensibility sort of piece. And at the end, you have this ability to kind of get explanations, generate documentation, and at the end, get this scoring pipeline that you can automatically, the scoring pipeline that you're ready to take to deployment, right? So for your various deployment requirements. And we talked some about that, extensibility capability. So, this this is an open and accessible platform, right? So if there's additional use cases, different algorithms, or you have IP about a particular feature engineering that's worked well for you, or you want to optimize for a particular score, Driverless AI is an open and extensible automatic machine learning engine, right? And so we have a whole catalog of additional recipes. So what happens is there's the recipes are in the box of Driverless AI. Then we have this catalog of recipes that are in the open source that you can add to it. And lastly, there's recipes you can just write from scratch, right? So you can extend and build your own recipe to complement what's already in Driverless AI for automatic machine learning. So now I want to go to a quick demo. Okay, so I'm using this environment called Puddle, and I want to create an environment so I can quickly choose an environment I want to use. I can give it a name. I can choose what kind of environment, whether it's CPUs or GPUs I want to use. Give it a volume size, set a setting to stop it, right? And that's going to launch a environment for me, right? So here, this is Driverless AI. So once I launch it, and this is actually a running Driverless AI. This is in the middle. This has been running for 28 minutes, right? So a little bit before we started this webinar, right? And it's built, every dot down here is a new model that's built, right? So this is done sort of automatically for you. And in that process, it's doing the selection of the algorithm, right? So the winning algorithm right here is LightGBM. But if I hover over this is XGBoost. This is an XGBoost algorithm. And you can see on the right the variable importance changes, and you could, if you look at the variable importance, like the first one is 74 there with weight of evidence. So I'm doing using a feature engineering technique called weight of evidence between page 0, page 2, page 3, page 5, and page 6 features to generate a new feature to get additional signal, right? So here it's entered the phase of ensembling at the end, right? And so this is going to continue to the end. So what I want to do is sort of start from scratch and how did we get to this, and then maybe what are the next steps, right? So from the datasets perspective, I have here's some datasets that are already loaded. I can add a dataset. I can literally drag and drop a dataset in, right? And as I look at the different connectors, let me see. Here, here's a sort of a more full list of the various connectors that are available, right? So I think we have something like 14 different types of connectors. So whether you're on the cloud, leveraging Hadoop, have a relational database, we can use a JDBC connector to connect to that, or we have a notion of a data recipe. So you can have a custom recipe to kind of anything you can get access to via Python and return a data frame, you can consume within Driverless AI. Right, so once you've sort of loaded your data, then you can start exploring that data, right? So here you can start kind of getting quickly understanding of the data, get a profile of that data. So in this case, in this demo, what we're doing is we're trying to figure out if someone's going to default on the payment, right? And so we want to build this model as quickly as possible, but we also want to build the best possible model in the shortest amount of time. And so this model is where we look at who's going to default on a particular payment. Let me kind of just move you along. Look at who's going to default on a particular payment. And so there's a couple of different features that are important. There's these historical lag features around, what's your payment amount for the last 6 months? What's your billing amount for the last 6 months? What's your payment history, right? So like, did you make the payment on time, beforehand, late, how late? Right? And then we have some demographic information. We can also kind of quickly get a perspective of what the data looks like, right? So as we kind of continue this journey and understanding the data, the next thing we want to do is kind of look a little deeper into the data, explore the data a little bit more. So one of the things that the data scientists often do is create hypotheses, and part of this process in data science is verify these hypotheses and build experiments to kind of keep learning about the data. And there's a whole process of exploratory data analysis, which can be very time-consuming. And in this case, what we're seeing is we're starting to leverage AI to do AI, and we have figured out, or Driverless AI has figured out, some interesting patterns that exist in the data, and they're showing to you. So in this case, there are 10, but sometimes there's 6, sometimes there's 13. It really depends what exists in the data, right? And so again, streamlining the process for you to understand what's happening. And so, for example, you can look at outliers. Like you look at bill amount 4, and there's a collection of outliers that exist for bill amount 4. If there's multiple outliers, you can kind of scroll through them. So here's payment amount 3, and you can actually click on one payment amount 3 and kind of see what is payment amount 3 value. So this will allow you to potentially start a discussion. Start a discussion with your data engineer about, well, how was payment 3 constructed? Where did it come from, right? Or you can start a discussion with your line of business. Is this a fair value to be within payment 3, or is this sort of an outlier that maybe we shouldn't consider, right? So it allows you to kind of explore the data and maybe do some amount of quality checks, right? So it's garbage in, garbage out. So before you start the experiment, is it worth, what's the state of where the data is at? And what can I more understand from the data? And here we can also generate a correlation graph. So each of these graphs have an explanation. So you can see here that that red means that there's high correlation. So red is actually good, right? Not like my other homework where red was bad, right? And so I can kind of like focus on the various what are variables or features of high correlation. I can focus on a particular value, right? And kind of see what are the variables that have high correlation, which is red, and low correlation is blue. So again, deepening our understanding of the data and facilitating that, leveraging sort of this automatic machine learning capability, right? And once we've done that exploration, explored the data, now we're really ready to start an experiment, right? And so we have some tools to make it easy to split the data and kind of get your training and test data, and I already kind of done that. And for the sake of time, I'm just going to get to actually predicting. So here we have our fantastic live demo prediction for defaults, right? And I can provide a test data set. If I needed to drop columns, I could. Drive AI automatically does bifold cross-validation. Again, this is some of the automation and the AutoML that facilitates making streamlining the process. Right, we can select what is our label, right, or the target column, or the example exists. So in this case, we're looking at default payments, kind of build and identify a pattern, or build a machine learning model on it. So again, we're starting to see AI and AI in action again here, where it's figured out this is a classification problem. Draws AI is suggesting these initial tuning parameters, right? So for a novice user who doesn't know how to program, this allows them to kind of get in. By the way, anything you do from the UI, you can do from Python and R. So if you're not a GUI fan and you want to get back to coding, you definitely can. So this is where automatic machine learning can be leveraged both by novice and experts. And so we also can, at a high level, give you a few new tuning parameters for the folks who maybe are newer. But don't worry, there's a lot of additional knobs if you want to do further tuning. So these initial knobs, these 4 knobs are on accuracy, time, interpretability, and what's the score. So what are you going to optimize to? So in this case, we looked at the data set, and we're suggesting that you leverage AUC as a score. You could always override that and select something else if you wanted to. And we're suggesting an accuracy of 5, interpretability time of 4, and interpretability of 6, right? And these range from 1 to 10, right? And so I'll quickly talk a little bit about this and run an experiment. So what's happening with accuracy? With accuracy, it's looking at what algorithms that you consider. So looking here at a constant, a GLM, a light GBM, an XGBoost GBM, right? And so it's suggesting these models for this, again, automating a selection of the algorithms, right? And it's also suggesting an ensembling of 8 models, of the 8 top models at the end, right? The other thing that actually has an impact around feature engineering. So what techniques do you want to use to better find signal in your data? And that's, they're often referred to as feature engineering. And so these are sort of mathematical, statistical techniques to find better signal in your data. So, as you kind of go up in accuracy, you probably see the set of feature engineering techniques add to and change, and your set of algorithms potentially change, and there's definitely an ensemble change here. So I'm going to go back to 5, and time is not in minutes or hours. Time is an effort, right? So this is really looking at the amount of iterations that you're going to kind of go through. And lastly, interpretability is, you can think of it as also kind of complexity. How complicated of a model do you want to consider, right? So in particular, in some regulated industries, like finance in the United States, there's certain algorithms that are considered models, algorithms that you can leverage to report on and explain in a regulated industry. So you want to use those algorithms, and you want to leverage only those algorithms, and maybe only particular sets of feature engineering techniques. So you don't want to make it necessarily too complicated, right? And so this can work with GPUs and CPUs. Again, this is part of the acceleration. So not just the acceleration in the automation of the tool, but also the acceleration in speed in leveraging compute to make this process faster, right? And so you can leverage GPUs, but it can also run just on CPUs, right? So I'm going to actually bring down the interpretability to 2 and run a quick experiment, right? So as we launch an experiment, Driverless AI, again, in that automation process, follows, it does some exploration, gives you some reporting on how imbalanced the data is. It detects the ID column and automatically drops that. It compares your training data to your test data and see if there's some major shifts or concerns that you might want to additionally explore. It also does a whole collection of additional checks, like, for example, looking for data leakage. So again, as we look at that complicated or potentially complicated machine learning workflow, right, we're doing lots of checks, you're leveraging lots of best practices and automating that capability and putting the auto in AutoML, basically. And so here we passed less than 50 seconds, and we've already built 2 models, right? And so the winning model is like GBM, and you can see each dot starts appearing, more and more algorithms appearing, right? Or more and more models being constructed. Right? In each iteration, there's a genetic algorithm, which is that automation of, trying different hyperparameters, different feature engineering to sort of streamline the process and build the best algorithm in the short amount of time, right? So this line is sort of tying together the various the winners, right? So if you see, for example, here's the GLM model, right? It's a little lower. Here's another live GPM model. So it's trying different algorithms, and it's also trying different feature engineering techniques. We give you lots of different metrics, so you can kind of see quickly the confusion metrics for key metrics. You can look at a precision recall curve, a lift curve, a gains curve, a KS curve, right? This environment is actually running with 1 GPU, right? So you just run with CPUs, multiple GPUs, right? And this process is going to go on for a while. So I'm going to do a little cookie show here and kind of let's look at something that's already completed. So here is a run that I did earlier, right? And the winning model at the end is it's an ensemble of 2 live GBM models. And at this point, I can do lots of things, right? I can score. I have a model I can score additional data with. I can try to understand what's happening in the model. So it automatically generates an auto report. So this is what the auto report does, and it's editable, right? So that, it could be Mike, the data scientist, and it gives you, almost 30 pages of documentation, very specific documentation about what was done, right? So what were the hyperparameters? What were the algorithms that were chosen? What was the feature engineering techniques? And again, this is part of that automation in AutoML to kind of streamline the process, right? And as you look at the most robust automatic machine learning, these are some of the capabilities that differentiate the leaders in this space. The other thing is that we kind of do, before maybe we want to deploy this model and we make it easy to deploy, we have a, let's interpret this model, right? So I can kind of look at a dashboard to kind of look at how to explain this model. So here we're doing a dashboard, and on the top left we're looking at a collection of canine models that are built. So there's a series of surrogate models that are built. But the nice thing about here is that this allows us to get things like reason codes. Right? So reason codes help you understand why a particular decision is being made. And so these explanations can be sort of global or local, right? So I actually chose an individual, so you can see that it's individual 7955, and typically page 0 and page 2 are the most important parameters, but for this person, really page 3 and page 0 are the most important parameters, right? And I can quickly, I can look at a surrogate model for decision tree on how did I get to that, right? Because of page 0, page 3, bill amount 1, I was able to get to this prediction threshold, right? And so this is also part of the automation, right? So it's not just the automation of building the models, but it's about explaining the models and building the reports around the models, right? And lastly, to kind of look at, the automation of being ready to deploy, so we have this thing called a scoring pipeline. So in the scoring pipeline, it includes a model and includes a mojo, right? So mojo is a model object optimized version of the model that includes also the feature engineering. So we build this pipeline with the feature engineering and the model that's ready to deploy. And you can deploy that with Java, with Python, with R, or even with C++, right? And so now we've, in literally a matter of minutes, we've been able to consume some data, explore the data, build some models, and not just build some models, but like really optimize how that model is being built, right, in the shortest amount of time. So look at different algorithms, hyperparameters, feature engineering, right, and then kind of go into looking at explanations, building an auto report, and within that, you're a click away from having a model that's deployment ready, right? So that's a quick demo, right? So if I go back to the slides, right? So automatic machine learning, it's about democratizing. It's a key factor in democratizing AI, right? Because this can be leveraged, makes it accessible by even more folks, and makes it streamlines the process for experts, right? So experts have a lot of knobs to keep fine-tuning the models, right? But in some places, I was working with a customer, and they really want to have a model factory. So they have a team, an existing team, and they have built 40 models that they have in production. But with the success of their AI efforts, now they want to build even more. So they want to go from 40 models to 400 models. So how do you go from 40 models to 400 models without, exploding the team and exploding your costs, right? So, automatic machine learning is a key factor in kind of going to scale your machine learning efforts, right? And, we saw the time savings both from the automation and from the compute perspective. And it's not just about building models, it's about getting those explanations. So, we talked about this as a whole journey. H2O recently just launched a H2O Learning Center. So you can find a whole set collection of tutorials to get started with, H2O3, with Java AI. You can learn more about automatic machine learning. If you're, completely new or more new to the space, or have some friends that are new to the space, we're also launching at the end of the month a series of free courses around AI foundations and machine learning foundations. So you can learn more about those. You can earn badges for what you do here. And if you wanted to try yourself, one of the things is you saw me do it, you saw some tutorials, sometimes you should try it yourself, right? Learn by doing, right? When you try it, then you really get a much stronger sense. So we have a tool called Aquarium, which is our cloud learning environment. So between the tutorials and Aquarium, you can kind of get up going in less than 10 minutes, right? And start exploring something similar to this. So starting to conclude, right? So automatic machine learning can help you accelerate time to insights, democratize AI, scale your AI efforts for both novice and experienced data scientists, and also help build your trust in that automation process. And this is going to get you on that road to help you make your company into an AI company. So, I'll have some links on additional resources at the end, but I think at this point, let's kind of open it up for questions. So, Shapar?
Thank you, Rafael. We have some great questions in the chat window. We'll try to get through all of them with time permitting. First would be, how do you compare H2O.ai to OpenAI?
H2O.ai, well, I think maybe what you're, so H2O.ai is the company. There's an open source project called H2O or H2O3, and sort of driverless AI. And that's also doing automatic machine learning. So if I was going to compare H2O3 and driverless AI, in some ways they're a little bit different tools, right, because of the environments they run in, right? So H2O3, it's basically if you have a big data science problem, right, where you're trying to train data on terabytes of data. H203 is one of the few tools that can do that and can bring automation to that. So that's kind of working within a Hadoop, Spark, and kind of Kubernetes environment. But if I just kind of look at the pure automation, right, we would need to kind of look at the level of feature engineering. So there's probably more advanced feature engineering that's available in driverless AI, and how much of the automation of the flow is possible, right? So things like the documentation, the explanations, is sort of a little bit part of the difference between driverless AI and H203's AutoML.
Okay. And how would an expert data scientist leverage AutoML?
Yeah, so that's a good question. So I think an expert data scientist, as you look at scaling the efforts, right, it can help, take some of the tedious tasks away for that particular expert. And also, the key thing is about, we talked about this open and extensible platform, right? So in that open extensibleness, this expert data scientist might have more IP, has studied the problem more, so they can do more fine-tuning, right? So they can bring their particular feature engineering techniques. Maybe they develop a custom score to evaluate the model, or maybe they're dealing with some very bleeding-edge algorithms, or they built their own algorithms. And part of automatic machine learning is let the best algorithm win. So let's try all these different combinations, permutations, and iterate through that to kind of get to the best model in the shortest amount of time. So, that open, extensible capability really provides flexibility for that expert to bring their expertise into the AutoML project.
Perfect. I am assuming the data set needs to be extremely streamlined. Does H2O have the capability to also help address the data preparation and cleaning?
Yeah, so the data, it like anything has to be, the quality is key in any analytics, right? So garbage in, garbage out, right? And so for that, there's a whole collection of things that driverless AI can kind of deal with sort of automatically. So it can deal with some recent data. It can deal with maybe not having the data exactly how the algorithms expect, right? So it can do some encoding for you. From the data preparation aspect, right? H2O is really focused on machine learning. And so, many vendors have existing ETL and data prep tools. Many data scientists are using Python and Pandas to do sort of data prep. So one of the things that H2O can do is has a notion of a data recipe, right? And so the data recipe allows you to bring in your Python code to do data prep. And so you can bring some Python code, use Pandas, and if Pandas is not scaling for you, we can also leverage Python data table to do data prep in your flow to kind of do further refinement of the data and then feed that into driverless AI.
Okay. What advantages would you say you have over a platform like DataRobot?
Yeah, I think that's a very good sort of question. I think that's something we definitely want to work with all the different folks that that are sort of interested in exploring that. So I would say, our GPU sort of acceleration, right? And, like many of these things, I think it's sort of best to try it. So how fast can you get to a winning algorithm, right? So we have seen DataRobot many times and sort of in face-to-face competitions. And so that automation of getting to the best algorithm in a short amount of time is key. And part of that, I think that, allows us to kind of improve on, some vendors in the industry is our advanced feature engineering capability, right? And the fact that it's an open and extensible platform, right? So it's not just about what's in the box, but what can you bring to the box, right? To kind of complement what the automation is doing. So we think we have the best in-the-box set of tools to automate machine learning, but we're not limited to that because we're an open and extensible platform.
Correct. Okay, great. You mentioned an open extensible catalog. Where can I learn more about that?
Yeah, I mean, so there's a bunch of different tutorials that you can kind of look at. So we have this Learning Center. So if you look at the Learning Center and kind of look, go to training.h2o.ai, there's a whole learning path around it. So you can kind of learn. There's open accessibility. We have a couple tutorials around recipes, right? That provides that accessibility. So just using a recipe or like building your own recipe. We also have this catalog that's available of all the open source recipes that you can also bring into this to driverless AI.
Perfect. And one last question. Are you able to run neural networks on driverless? Yeah,
absolutely. Right. So as you look at the collection of algorithms that's in driverless AI, right, we have support for TensorFlow, right? So if you're building a model for something like NLP and kind of doing document classification, we'll leverage TensorFlow. And again, it's about the best algorithm, have the best algorithm win. So you can kind of automatically turn on all the different algorithms and have driverless try all of them and see which provides the best model, right? And some model, like neural nets, are particularly good for things like image processing or NLP, right? And we're just in the process of also adding PyTorch into that same ecosystem, right? So absolutely, we're definitely leverage neural nets, but remember, we want to use the right tool for the right problem.
Perfect. Thank you, Rafael, for taking the time today and doing a great presentation. I'd like to say thank you to everyone who joined us today. The presentation slides and the recording will be made available on our Bright Talk channel. Have a great rest of your day.
Thank you.